Hello, this is Brenda Wingard-Haynes, and this is Chem 207, and we are on Unit 1, Part 2, the structure of the atom, periodic table, and the formation of ions. Most of this should be review, and so this video, audio file, whatever it is you want to call it, is constructed to either enhance what you did in the classroom or to exist as a flipped assignment, something that you would do outside of the classroom. Now we're going to begin right here, okay? For this part of the unit, you will have additional definitions that you will be responsible for. They'll not be covered in class. You also need to come to class making sure you know symbols. Symbols for common elements. We will not spend much of any time on that. However, there will be some new material largely with respect to where the electrons are and exceptions to the octet rule. All right, so let's remind ourselves of the composition of the atom. For our purposes, we have three subatomic particles, your proton, your neutron, and your electron. And those make up the atom, which is the fundamental particle of matter. Therefore, we do need to go back and remind ourselves that matter is anything with mass which occupies space. So what that means is the only thing outside of matter for our purposes is energy. And we're going to spend more time in this class talking about energy because it's germane to biochemistry. Okay, so I guess I should put on here not energy. Okay, you should remind yourself that the subatomic particles are measured in terms of AMU, which is the atomic mass unit. Okay, and so for our purposes, we are going to make our masses, charges, and locations relative. So the relative mass of the proton is 1 AMU, a neutron is 1 AMU, and the electron is essentially massless. It's not really zero, but it's so small within the parameters of what we talk about that it drops off with significant figures. Charge +1, 0, -1, and the location is that the proton and neutron are within the nucleus, and the electron is outside the nucleus, and it's the outside the nucleus location of the electron that causes a growth opportunity for us to learn something new. So if I ask you which two subatomic particles contribute to mass, you would say the proton and neutron. If I ask which two subatomic particles contribute to charge, that would be the proton and electron. So if you change mass, well, okay, let me say it this way. If you change protons and neutrons, you change mass. If you change the proton to the electron ratio, you get some kind of different charge change. And we'll come back to what happens when you change these in just a minute. Okay, elements are what you see on the periodic table, and they are characterized by the number of protons. So when you change protons, you change elements. Okay? If you take your element and break them down any further, okay, so you could think of your element over here, your nucleus, proton, neutron, electron. If you break them down any further, you have a pile of protons, you have a pile of neutrons, you have a pile of electrons. Okay? So, your element is determined by the number of protons that there are in the nucleus. All right, now your elements are named for a variety of reasons: who discovered them, mythological figures, Greek and Latin languages, etc. Okay, so your symbols are on the periodic table of elements, and you are responsible for knowing what these are. Okay, Pb is lead, Fm is fermium, Ti is titanium, C is carbon, O is oxygen, and so on and so forth. Okay, so here you go. You must know the common symbols. Okay, any obscure ones or ones that we just don't really talk about a lot, I would give you those. But you know, I would expect for you to know that Fe is iron and Na is sodium, K is potassium, P is phosphorus, and so on and so forth. Okay, now when you have your atom or your element, an atom is a singular unit, you can think of the elements as a collection, you can write them in terms of a nuclide symbol. And this is not anything new either. So your nuclide symbol I can write kind of like this, okay? Where A is equal to your atomic number, which is equal to your protons. B is equal to your mass number, and remember that would be the protons plus neutrons, okay? C is going to be your charge, which is equal to your protons plus your electrons, which are negative. By the way, I'm at home. If you hear my dogs in the background, it's because they're barking at something in the backyard. All right, so the question is, what happens when you change the ratios of any of these? When you change your atomic number or protons, you change your element. When you change neutrons, or you change your mass number, you have what we call an isotope. When you change your electrons, you get what we call an ion. You get a charge on your particle. So let's look at this group down here. All of these are given the symbol C, which means all of them are carbon. By definition, you look on the periodic table and you see that all of them have 6 protons. 6, 6, and 6 protons here. What makes these differences is the number of neutrons, okay? So remember, 12 is our mass number, which is the protons plus the neutrons. So 12 minus 6 means we have 6 neutrons. For this one, we have 13 minus 6 is 7. So the difference between this atom and this atom is that we have an extra neutron. The number of protons have not changed. 14 minus 6 gives us 8. Okay? So we cannot change the number of protons. What we're changing is the number of neutrons. Okay? Now the electrons here is determined by the charge, and the charge is 0. So we have 6 pluses for protons, plus how many electrons are going to give us a neutral charge? Well, there'd have to be 6. All of these are neutral. So all of them are going to have 6 electrons. Okay? So the only thing that we have changed in this group right here is the number of neutrons. For all of them are carbon. They just have different masses. Okay, let's try a couple more here. Okay, Mg is magnesium. When you find magnesium on the periodic table, you will see that it has 12 protons. And usually and typically the number of protons are left out because you can just find them on the periodic table. So we have 12 protons. Our neutrons, 24 equals 12 plus the number of neutrons, means we have 12 neutrons here, 12 neutrons there. So the only difference between this one and this one is the charge. For the first one, our charge is 0. We have 12 pluses plus how many minuses are going to give us 0. Well, clearly we have 12. A 2 plus charge means I've changed my number of electrons now to 10. All right, so when I lost electrons, I got a positive charge. We want to remember that. Okay, 23 Na. Na is sodium. Sodium, when you find it on the periodic table, has 11 protons. Okay, neutrons, both of these have a mass of 23. 23 equals 11 plus the number of neutrons, so we have 12 neutrons here, 12 neutrons here. Again, our number of electrons will be 11. And when we get a +1 charge, that means we have 10 electrons on this one. So, what we have between magnesium 2+ and sodium 1+ is that they have the same number of electrons. And that is what we call isoelectronic. Iso is a prefix that means same, electronic means electrons. Okay? Now let's go to the other side of the periodic table. And Cl is chlorine. And we have 17 protons there, so we can put it on our nuclide symbol if we wish. Both of these are chlorine by nature of the fact that this atom, or this nucleus, has 17 protons. That's what defines it as such. Mass of 35 tells us we have 18 neutrons. Same mass, so we have 18 neutrons. So nothing has changed here. What has changed is the charge. We go from neutral to -1. So 35 equals 17 positives plus how many negatives are going to make that neutral. And that is 0. I'm getting ahead of myself. I'm sorry. 17 electrons here. And on this one, we have a -1 charge. 17 pluses plus how many electrons means I have 18. My point being is that when I gained electrons, I gained a negative charge. Okay? And then last but not least, O is oxygen. If you see it on the periodic table, you see there are 8 protons, so we're good there. This particular atom has 8 neutrons. This one also has 8 neutrons, 8 electrons. And then, again, we have a -2 charge. 8 pluses plus how many negatives is going to give us -2. Again, that will be 10 electrons. So, magnesium 2+, sodium plus, oxygen 2-, all have 10 electrons, and so therefore they are all isoelectronic. So, for the purposes of summing this all together, we want to remember what happens when we gain or lose protons. We get a new element. When we gain or lose neutrons, we get a different mass. Okay? And these are called isotopes. When we gain or lose electrons, we get a charged particle. And this is called an ion. Okay? When we lose electrons, we get a plus charge. When we gain electrons, we get a minus charge. Okay? So your positively charged ion is called a cation, and your negative charged ion is called an anion. Okay? Now this is a good place to end this segment. So please go back into your book or your directions in class and practice this, because the next thing that's going to come is utilizing the notion of isotopes to show the difference between mass number, which is something that you see here or here or here, versus atomic mass, which is what you see on the periodic table.